Good morning, everyone. It's good to be here hosting this Astute 2020 webinar this morning. I can see electronically people pouring through the doors, which is always a difficult moment as to when to start, when you can see people still coming through live. But I think listening to me is not too interesting, so I'll make the introduction and the welcome, and we'll kick off this morning. It's good to have so many online registering this morning. Quite clearly, this has been a difficult period of time for the last 7 to 8 months. And the work of Astute 2020 has been quite vital for us as we've had to work scurry, you might say, on bringing industry, academia, government into public health and care and all the other support mechanisms that we've done. Of course, we have been over the last number of months talking about restart and how to restart quickly. And again, I firmly believe in the role of Astute 2020 to play a significant role in doing that. Well, it's a great opportunity this morning to be able to explain more of that. We have a number of panelists and we'll introduce them one by one as they present to us. But the idea is to shorten their presentation to give us a time for the Q&A session later on. The last 6 months have taught us that business as usual is just not possible. And there are so many disruptive things, not in the market or in the world itself, but from the technology, materials and processes that we have. And how can we get the right level of support, and how can we get the right level of insight to ensure that we choose the right things that we might need to make success of our businesses and our industries. And yet also, what have we learned? How to collaborate, how to work together, what partners should we work with? All these things have been condensed significantly during the CV19 period and continues on right now. And the lessons learned from that can be applied now through the way that we cooperate and work together on these things. The whole thing here is to bring huge advantage in speed. We've always known that. Of course, I was acutely aware of that during this period of time, but that remains the case. To be competitive in the future, be productive in the future, the speed of applying technologies into our businesses is quite vital. Four short presentations on an overview, and then more specific examples on driving productivity forward, on modeling risks and opportunities and how important that is to do that, rather than just the old trial and error methods that we have, and then working into sustainable materials in particular, and the expertise that can be offered in that area. After every presentation, there's a poll. That poll will take a few seconds for you to think through. We won't be able to give you minutes, unfortunately. We'll give you a bit of time, and it's there for about 2.5 minutes, but we'll pause for 30 seconds before we go on to the next presentation. Please use the poll. That feedback is quite vital to us. And then there's also the Q&A button that you have down there. And we're looking forward to live questions. Some might be answered in the sessions. Otherwise, we'll try to get to them. But the commitment today is that any question that's asked by registration or in the live question will get answered either in this session or by a written answer a little later. With no more delay whatsoever, I'm now very pleased to introduce our next speaker, and that is Professor Hans Sainz from Swansea University, Director of Astute 2020. Thanks, Hans.
Good morning. Thank you very much, James. I'm waiting for my slide to come up. Okay, starting now, Astute 2020, we've been operating since 2010 in Wales. It's a partnership of Cardiff University, Swansea University, Aberystwyth, South Wales, and University of Wales, Trinity St David. And on the right-hand side, you can see the engagement we had with industry, a typical M4A55 corridor, but we work throughout Wales. It's very important, and we support companies throughout Wales. In the first 5 years since we've been in which we evaluated, we generated 200 million economic impact, and the partnership is now in its second phase. Next slide, please. The industry support which we offer to companies is for research, development, and innovation to increase competitive productivity and also to future-proof operations. And certainly we've seen in the COVID crisis now how difficult this sometimes can be and how challenging in very much compressed time frames where things need doing. So engaging with companies, stimulating ideas, challenging what we know, and looking for the next solution is really quite vital to us, engaging with companies. The projects are industry-led, so they're not coming from us, and so companies define them. You work with us, and hopefully with this we can stimulate transformation and sustainable growth. Next slide, please. The benefits which we can bring to working with companies, naturally, we've got a lot of expertise in universities, and Astute is a mechanism to bring this into collaborative projects with companies. So we've got access to the academics, but we also have employed a number of highly qualified researchers and technical experts, and their only job is to work on collaborative projects with companies. We also can access state-of-the-art equipment and research facilities at the universities to underpin the projects and complement them. And we apply this to intelligent systems, advanced techniques, and naturally we've also got sometimes bespoke software. Commercial softwares don't always solve all the problems, so we need to use sometimes our own software to come to solutions. And each project is fully supported by a team in Astute and a technical manager to work with the companies to make sure that their project is delivered on time and delivers what it needs to. Next slide, please. The focus for manufacturing, as we've defined them, is grouped into 3 categories. Advanced materials technology, we hear more about those later. Computational engineering, modeling, and manufacturing systems engineering. So I don't want to dwell too much on it. There will be presentations about it later. All the work is done collaboratively to work with companies to make sure that this knowledge exchange between companies and academia works, and to support high-value manufacturing in Wales. Next slide, please. The collaborative projects, there are multiple components to it. Key is really that both parties are very active in it. It's the Astute teams and the companies, and the inputs from the companies could be in staff time, materials, equipment, consumables, and so on. The outputs is hopefully we've got a solution to a problem which wasn't there before. So it might be IP, it might be know-how, and so on. And we share those outputs in relative to input, and we share also the risk of what comes out of it. Very importantly, the projects are very well defined. Each party knows exactly what part they need to do, the dependencies, deliverables, and milestones. And the team work together to solve the problem jointly. But important is that each party carries its own costs, so no cash exchanges hands. So no money goes from us to the company, and no money comes from the company to us. And also importantly, the company inputs can actually be used for R&D tax credits because all projects are research-based. Next slide, please. I think that's the end of my presentation, and we'll go now back to James.
Thanks, Hans. I'm delighted also now to present Professor Mohammed Naeem, speaking on driving productivity forward from Cardiff University. Thank you, Mo.
I can't hear anything.
I'm about to say the same thing. I can't hear any volume at the moment. Live was always great, and it seems that we've got a few smiley pictures arriving, but not volume yet.
It worked in the test run.
Mo, I'm wondering whether...
I think I better take over, shall I?
Yeah.
Okay, this was pre-recorded just to ensure compliance to the schedule and time compliance. So perhaps if the problem is not a slideshow, is it? So
things that will allow us to compete.
We've got volume. We're going to go back to the beginning and start that again.
and who are here today during the webinar. What we thought we would do is just to highlight some of the major challenges, or some typical challenges, that we have faced as organizations during the COVID crisis, and then to translate those into opportunities, some generic opportunities that will allow us to compete both at the local, national, and global level. And these are some of the challenges we've brainstormed ourselves with regards to some of the things that organizations have faced during lockdown and post-lockdown. So, for example, to comply with social distancing requirements during COVID, we have to look at ways of maybe laying out the factory differently, or reconfiguring our factory differently. We may not necessarily have the physical movement of assets, but the way we manage our working and the way we do things might change. Another example is obviously automation, to avoid people actually handling components and equipment. So perhaps moving towards this vision of the Industry 4.0, fully automated factory. Also, an example is more recently organizations looking at developing new products to meet the needs of the nation and more globally as well, with regards to introducing new products like PPE. We work with organizations in terms of helping them develop and manufacture visors, face visors, and overalls. And maybe not through the street, but through other means. We've also been working with organizations in the foods and drinks industry, drinks industry in particular, looking at translating the production from making alcohol to drink into alcohol for hand sanitizer. One of the things as well that organizations are facing during the COVID crisis was looking at local suppliers, especially due to the big ramp up in demand for things like PPE, and moving away from global sourcing to local sourcing. And also, as we've all faced during this time, is actually working from home. And we'll look at opportunities now from working from home, and how we can help organizations do that in a manufacturing context. So what we have done here with Plus Opportunities is just translate some of those COVID crisis-specific challenges into generic opportunities, things we may have done ourselves anyway in order to achieve operational excellence, continuous improvement, but sometimes the crisis actually gives us the motivation to do things more quickly. So for example, with regards to the first one, relating directly to the previous challenges from the previous slide. So with regards to social distancing, well, actually, looking at our factory layout, looking at ways to streamline our material flows, our process flows, gives opportunity to improve in terms of reducing non-value-add activities and enhancing the value add throughout our total manufacturing process. With regards to automation and enhancing automation, looking at robotics, for example, to reduce material handling, the opportunities offered by our research in robotics. We can look at ways to reduce the amount of handling actually required by individuals, and looking at ways also for individuals to be working with the robots, sort of a whole systems perspective. When looking at introducing new products, obviously that gives opportunity then for us to look at how we can become more agile, more flexible, in particular agile in response to volume changes, and offering greater variety in terms of our product range, in terms of what we can actually manufacture, to look at the pros and cons of make to stock versus make to order, and so on. And then in terms of looking at local supplier, well, there's this opportunity for us to look at right shoring supply chain, looking at where we actually are sourcing from, looking at critical products, products that are essential or components that are essential to the product that we make, vis-a-vis sort of more commodity type products. And we may look at a supply chain in terms of what can be sourced locally and should be sourced locally versus what we can actually source globally. And then the last one there, just in terms of home working, looking at the opportunity there is really reducing the need for physical office space and assets as well, physical assets. What I'll do now, after this highlighting these generic opportunities, I'll now give you just an overview of some examples, some cases where we've actually applied some of this manufacturing systems, engineering methods and opportunities within specific companies. This gives you an idea of the range of manufacturing sectors that we have worked with. So the first one here is medical devices. This is a particular pumps for bed sore blankets. And in this particular example, the first example, we looked at looking at new layout and in particular looking at new ways of working. And in this case, via gravity feeders for materials handling, so avoiding direct contact in terms of relating it to COVID, avoiding direct contact between operators. And this kind of gravity feed system and new layout led to productivity improvements. The next one is an example of braking systems assembly in the automotive sector, the development of cobots, where we have within the same space both operators and robots. But the main research challenge there is working safely. And in this case, there will be no longer a need for robots to be hidden behind cages. The next two examples are both two different companies actually, but both in analytical equipment manufacturers. The first one where we looked at understanding and documenting current manufacturing processes, looking to enhance value-add activities within the manufacturing system, and identifying ways to enhance capacity. So the various modeling techniques were used here, visualizations, process mapping, and computer simulation as well. The second analytical equipment manufacturer, we looked at sourcing strategies as well as manufacturing operations, but in particular looking at a new way of sourcing, not just simply looking at cost or price, particularly for various critical components, looking at how we can enhance the resilience of the supply chain. So looking at the capabilities of suppliers over and above low cost. This was particularly relevant because there were lots of delays with the critical components coming from overseas suppliers. So we're looking at things like the supplier ability, capabilities in terms of agility, flexibility, as well as efficiency as well. The last example, which relates then to the remote working, this one is a joint venture between Cardiff and Aberystwyth with a Brindley company, looking at the development of an app to be downloaded onto a smart device that allows maintenance managers to work remotely from a specific factory. So allowing them real-time remote monitoring of the production systems to minimize downtime. For example, this maintenance manager had a number of different operations to look after, and wasn't necessarily required in any single factory.
Okay, thank you, James. Thanks. I'm glad you worked eventually.
Thanks, Mo. That's great. Now we're going to launch the poll, and you'll see at this time 5 key questions. Feedback on these things are quite significant for us. So the poll's just arriving on your screens now. You may not quite finish it in time. We prefer you to think it through, but we'll give you about 30 seconds now to just working through that. And it tells me at the bottom that I can't vote, unfortunately, but I guess my time on making industry decisions have gone now, so it might be appropriate. So I mentioned to you that last couple of questions are about localization of supply chain. As Mary's just been speaking about, what we found dramatically in the last 6 months is a real need to deepen the supply chain for resilience on all sorts of ways of doing it. Make sure that you're scrolling down on the poll to see the next questions. Last one being remote working and how it's allowed us to rethink. Home working was the first word, and then it became remote working. And I'm not so keen on the word remote working because it sounds like we're all cut off from each other. So I'm trying to impress on Welsh Government that maybe we should call it local community working. So at least the local economy is also impacted if you actually just walk into the town centre and spend an afternoon working there rather than always just in the front room where I am right now, which is not painted green, by the way. I think that's probably all of the time I can allow you to complete that poll. And now we will move forward into the next session. That will be presented by Professor David Gethin. He's not currently live with us, but it is pre-recorded, and we hope he'll be able to join for the Q&A later on. And David is going to take us through modeling risks and opportunities. You can see the poll results there later. I'm sure we'll publish that for you all to see a little later. Thank you for that feedback. Over to David remotely.
Hello, I'm David Gethin, and I'm going to talk to you about the modelling opportunities offered by Astute 2020. We all understand the challenges that industry faces these days. These challenges can be associated with new products and processes which are there in response to the market demand. Other challenges that are faced are those associated with developing new in-house technologies to improve the self-reliance of businesses on their innovation platform. The challenge of looking for design for manufacture and sustainability, and the challenge of designing processing systems for environmental impact. On the next slide, we'll set out how Astute 2020 can assist in addressing some of these challenges. Astute is a brand that's been working with Welsh industries for a period of around about 10 years. During that period of time, we have worked with businesses to support the development of new products, to support development of existing products, and to support development of process capability. And we can point to a number of successes in each of these areas. In modern terminology, Astute has been able to create virtual twins of the product or the process, and that can then be used by business for decision making. Astute offers opportunities to undertake computational modelling, and the expertise in Astute can be set out under three main headings. Those are structure mechanics, whereby we deal with statics, transient dynamic, and modal analysis. In fluid dynamics, where we deal with mixing, separation, phase flows of fluids and gases. And the third area, which is thermal, electromagnetic, and acoustic. And of course, we can bring those all together into complicated multiphysics modelling. And these have been used quite successfully to reduce prototyping cycles to enhance product and process performance. We will now look at two industrial case studies that have been undertaken by Astute. The first is aluminium tray forming, where the challenge is to form a perfectly rounded bead on the edge of the tray so they can be processed successfully in subsequent packaging operations. The second is laser trimming of a reverse extruded aluminium can, where the wavy edge around the top of the can must be removed by laser machining, and any particulate that is formed must be removed from the can. We now look at the example of aluminium tray forming. And essentially, it comprises three steps: deep drawing, wiping, and curling. Deep drawing is the way in which we manufacture the body of the tray itself. And this is a complicated process in that you have to have a large deformation of what is an originally flat sheet of material. There is contact between the punches and the dies, and there's friction there. And again, these parameters need to be incorporated into this part of the deep drawing module. The wiping stage is whereby we take the flat edge formed at the top of the tray and bend it over as a wiping cycle. And that bent over edge in the curling cycle is then rolled over to form the bead at the top of the tray. The next slide will show an animation of this process. This slide will show you the animation of aluminium tray forming. The sequence will show you the deep drawing and the wiping and the curling stages of the process. It'll all appear very much as a sequence of complicated and controlled tool movements. This slide shows the outcome from the tray forming simulation. And inset, we see an example of the defect on the rolled edge. In doing this work, Astute worked very closely with the business partner, and at the end of all of this, identified 3 potential solutions to address the problem of the tray edge defect. These potential solutions are now being carried through and tested further by the company. This is the second industrial case study, whereby we're looking to trim the reverse extruded aluminium can. It's a 2-stage simulation. The first stage is the laser trimming itself, whereby we actually generate some debris, particulate debris. And the second stage is to look at the flow and ventilation in the can in order that we can remove that debris from the can prior to it going on to the next stages in operation. This slide shows an example of the laser cutting process. It is a complicated process to simulate in that it has a multi-phase flows, i.e. it has liquid phase and gaseous phases present. It is complicated by virtue of the fact that there's a melting taking place, and if melting takes place, then the material properties are clearly temperature dependent as well. The model also has to account for the energy that is deposited onto the surface of the workpiece by the laser itself. What we can see here is a laser beam radius, which is typically 50 micron to give you an indication of the size. And what we see in the animation on the right-hand side of the slide is the penetration of the laser into the workpiece and the removal of the particulate from the workpiece as it goes through. This slide shows part of a parametric study into the ventilation of the can in order to remove the particulate. It should be noted that in this study, the can itself is rotating and that a gas jet is directed across the can at 0 degrees, which is across the diameter of the can, or at 15 degrees or 30 degrees, which is there to introduce a level of swirl within the can itself. The model is complex, it's multi-physics, in that there's a particulate phase and a gas phase, and that the two interact. And the aim of the study is to look at the way in which the gas phase will cause particulate movement out of the can in order to clear the can of debris. This slide shows the outcome of the parametric study presented in the previous slide. And what we see here is that, generally speaking, at 0 degrees, 15 degrees, and 30 degrees, there is little benefit in that around about 48 to 51% of particulate remain within the can. Needless to say, there are other parts of the parametric study which showed that this was there was an effective method of particulate removal, and further work is ongoing at this time in order to improve the understanding of the ventilation process. So the outcome of the work on laser machining and can evacuation has developed what is really a process virtual twin, and that has aided the understanding of a challenge that has been in existence for a period of around about 7 years. Complementary to this is the fact that the MD noted that this approach to solving this problem should have been taken place much earlier, and the company is now actively pursuing the opportunities that have been provided from this simulation study.
Thanks, David. That was really good. I could have watched that for a bit longer. And I love the fact that we didn't get to know what the real perfect answer was yet. The ability to run so many different trials quickly is great. Now the poll has just come up again. This time you have 5 further questions to work through. I'll ask you to do that. I know that you're all going to be interested in the answers and they don't stay long enough on the screen, but I'm sure we'll get feedback on that later from Astute 2020 on the subject. So just progress that for another 25 seconds, and then we'll move on again. I'm hoping that circular economy concept is something that you are familiar with. If not, I'm sure Astute 2020 and many colleagues and in industry and academia could speak more on that, but the ability to reuse, to ensure that we're extending life of valuable assets and materials, if you're not familiar with circular economy. Openness to work in collaboration. And I could speak pretty much on PPE or ventilators or CPAP devices or testing kit sets or diagnostics. Time to market on these things over the last 4 or 5 months just has decreased amazingly, but predominantly because we put parties together to work together to ensure that they could get to the customer and to the market quickly, but also have all the right help and guidance to achieve that. I think that's time up for us. So we'll wait for the results to possibly click on the screen, but we're going to start to move forward. And again, I'm sure you want to look at those results, but I'm going to move you forward again. And very pleased this time to be introducing Dr. Gavin Bunting, who's going to speak on sustainable materials. Over to you, Gavin. Thank you.
Hello, I'm Dr. Gavin Bunting, Deputy Director of Astute and Associate Professor in the College of Engineering here at Swansea University. So today I'm going to give an overview of some of the world-leading materials research support available to companies collaborating with Astute. So Astute has the capability to work with companies on a range of different classes of materials, from metals and alloys, polymers and composites. We can examine and evaluate microstructures and measure microscopic properties as well. We also have the capability for additive manufacturing of different materials. So I'm going to give an overview of the facilities available and end with an interesting recent case study. So to start with, optical microscopy. We have a range of optical microscopes, the one pictured here being the Keyence VHX1000, which produces an image with around 20 times the depth of field of conventional microscopes. It also combines stepper motor precision with fast image processing to capture a series of images, focusing through the sample height range, leading to an in-focus image of a 3D surface. And also allows for 3D profile measurements such as volume, distance, or angles to be measured up to an accuracy of 1 micrometer at a magnification of 1,000 times. Optical microscopy can be performed on cross-sections of materials, and we have state-of-the-art capabilities for metallographic preparation as well. Scanning electron microscopy. So we have 3 SEMs, each with different capabilities. And electron microscopy allows us to achieve more detailed resolution, with this one pictured here having a resolution of 0.8 nanometers. You can look at uneven objects, such as fracture surfaces, something I have significant experience on, spending a lot of my PhD analysing fatigue fracture surfaces of critical aerospace alloys. You can also evaluate metallographically prepared surfaces as well. The SEMs are also equipped with energy dispersive X-ray analysis, which can reveal the chemical composition of, say, different phases or inclusions. In addition, there is also a focused ion beam, which can accelerate ions to selectively mill out areas of a sample to study composition variation as a function of depth. X-ray microtomography. So this allows 3D imaging of materials within a structure. So the research from this facility produces some really interesting images. A couple of weeks ago, the BBC showcased the work of Professor Richard Johnston in digitally unwrapping mummified animals from ancient Egypt. And the image here is showing the product of this research. So you can get full 3D imaging of structures that are below the surface. So that's it on the microscopy side of things. Next, I wanted to highlight our metal additive layer manufacturing expertise and facilities. So a lot of you will be familiar with 3D printing, and as well as your common polymer 3D printers, we also have state-of-the-art metal additive layer manufacturing, which prints directly from metal powders. This can achieve very intricate shapes that can't be produced by traditional casting techniques. 3D printing can cut material consumption and CO2 emissions within certain applications. It can also support design optimization and is useful in low volume production scenarios, such as spare parts for an aircraft where they're printed to order. So automotive, aerospace, defense are currently the largest manufacturing sectors using this technology. However, it's also now being used within dental printing, medical implants, and device printing and product creation. This is an example of one of the ALM machines, Renishaw machines. It works by a bed of powder is laid down, the laser scans the surface and selectively melts powder particles that correspond to the region of a component. It's built up layer by layer as more powder is deposited. Unused powder can then be removed and reused. We also have a post-processing facility called a hot isostatic press, which provides a combination of high temperature and high hydrostatic pressure to close up any residual porosity. So that's it on the facilities. Next, I really wanted to highlight, okay, what's the current pandemic pose for kind of material selection and materials challenges? It poses challenges for us all. There's some specific materials challenges associated with COVID-19. For example, the need for sterilization of products or other cleaning techniques to be applied. Need to consider implications for the materials. Will they withstand temperatures and/or chemical agents used? Need for antimicrobial products and coatings. New ways of doing things post-COVID may lead to demand for new products. Also, as one would expect, there is need for more advanced medical products and devices, and it is an example of this I want to highlight next. So Corona Vent 1. This case study provides an example of how Astute rapidly responded to urgent need for manufacturing a prototype ventilator. The ventilator was built quickly from local parts and can be used even for patients with severe coronavirus. It was built within 10 days from locally available materials and skills. And I've got a video now showing this.
The Corona Vent 1 was built in 10 days from commonly available materials using locally available skills. It has the minimum possible number of specialist medical parts. It's completely optimized for the types of lung problems seen in COVID patients. We're currently developing Corona Vent 2. The differences from the initial prototype are that it's splash proof. The gas now enters through this port here. The check valves can be any design that you have available. The exhale gas comes through this diaphragm valve, which again can be made by 3D printing. It can be machined from stainless steel. If you wish to clean the inspiratory side of the system, the bellows unit unclips on the inside and the whole thing is extracted through the end here. So the entire gas pathway can be dismantled for cleaning, but particularly the expiratory side is just this part here, which comes off very quickly.
So I think that was an interesting case study showing how we responded quickly and efficiently to produce a prototype ventilator. So to summarize, we have leading edge materials analysis and characterization facilities supported by world-leading academics, and we can work with companies responding quickly and efficiently to help them innovate and develop new products and services. Thank you.
Thanks, Gavin. and I'm sure there's a lot of interest in what's been going on in there. And I congratulate you on pronouncing all those difficult words that I heard you speak about. But we're on to the poll on this one. We have again 5 questions to answer on the poll. Just give you the 30-40 seconds to just quickly run through those answers. So I can see a live question about whether we'll share this. I'm absolutely sure we'll share this. I don't know how we're going to do that, but I'm sure Astute 2020 will be willing to share that perhaps in the feedback, or if it takes a bit more time, we'll get it to you at some later date. Apologize, there are 4 questions. Don't look for a 5th one. There are 4 questions on this at this time. One of the key things we're going to get to on the resilience of supply chain is the fact that alternative materials, disruptive material conversion, but in particular in the context of what we put into the ground still, or what we send abroad for recycling, we'll find significant challenges coming in this as we seek to decarbonize and work to a carbon zero future. A few more seconds and then we will start the open Q&A session. We have done remarkably well on time. We're about a minute or 2 later than we'd hoped for, but we'll go into the formal Q&A, the questions you asked at registration, and then I hope to get to the live questions. So do continue to populate the live questions. Last 5-10 seconds on the question on the poll. And all these things, intuitively, your first answer is the one that normally works. Second guess or start to work out what you should be saying is not what we're looking for. So we'll close that there now, and then we'll start to open the Q&A session. We have quite a number of formal questions. These are of some worry, so I'll start mixing in some of the live questions as well, just to keep the panelists on their toes. Unfortunately, David's not been able to join us for the live Q&A as far as I can see at the moment. So we'll continue on, and I'm sure the Gavin, Mo, and Hans will do their best to answer anything that we were going to push towards David. Hans, I'm going to ask you first. This is really to do with the support that Astute can provide the manufacturing business and the costs incurred for the business. I do know that you, I think, made it fairly clear in the presentation, but perhaps you want to add some extra comments at that point about support and costs of the Astute process and support.
Just to reiterate the answer I've given earlier and to explain a little bit more, basically, very clearly, the projects we run are collaborative, and there will be a team in the collaborating industrial partners, and there will be a team in Astute, and both teams will be supported from their own organizations. Then other costs might come up, for instance, trials and so on. And we look then during the definition of the project proposal, who carries this cost, whether it's the company, whether it's the university or the Astute team, the labor cost and so on. And then once the project plan is defined, we'll deliver against that. But key is really that we can't give money to the company to do things, but in return, we also don't expect companies to give us money. So it's a truly collaborative effort where everybody has got clearly defined tasks and contributions, but they carry their own costs.
Thanks, Hans. Okay, well, I'm going to move quickly on to question 2. Again, asking each one to be brief, but apart from the COVID topic, what's new, what's changing, or what is now changing for Wales? And it's an open question, so I'll start with Gavin on this occasion, and then to Mo, and then to Hans. Gavin's on mute. Yeah, great.
Okay, so what's new, what's changing for Wales? Well, as I mentioned, as you mentioned earlier, James, one of the areas I kind of focus on circular economy, which I'll bring up later as well. And this is one of the things where government policy is moving towards a position where products will be required to be designed to have a longer life, be durable, upgradable, repairable, using recycled content. And this is an area where Astute can help industry think about how they respond to these areas, where it's in the design and expertise, computer modeling, and as excuse me, as thinking about enhanced product performance, and we've worked with companies to help evaluate properties of materials and recycled contents to meet these new requirements.
Thank you. Mo?
Yeah, thanks, James. I mean, there's a number of things coming over the horizon. Dare I say the B word, the Brexit word. That's obviously going to be still going to be a major challenge with all the uncertainty that's involved. But I mean, there are opportunities as well. I mean, one of the things the government's very interested in, UK government in particular, is the issue of free ports, how we ensure seamless flow across the whole supply chain. I mean, the free port opportunity, I think, can be coupled with the technology as well. Things like 5G, where we can track and trace products, components throughout the whole supply chain. And also coupled with that, obviously, I think it's related to another question we have on automation, things to do with finance as well, you know, blockchain, ledgers, and so on. And there are people working on this. And government is trying to sponsor research on this as well, you know, intelligent logistics and so on. So I think how we cope with those multiple challenges, as it were, Brexit, new technology, and putting them together, and how we adopt those technologies to satisfy this concept of seamless flow across the whole supply chain.
Excellent. I'm just going to link to Matt Allen's live question on, is there an opportunity to automate business processes in manufacturing, logistics, finance, stock control? You've just mentioned there. Matt, we'll put a more full answer into that one there, but absolutely, definitely, whether you call it automation or digital twinning or whatever, or continuous improvement in the processes within that, this is definitely an area that is significant. We know indirect costs are always of great concern, as well as quality of data. So I'm sure that's a yes to that one there, and we'll answer that more fully, Matt, in it. Hans, I'll just come back to the original question. What's changing for Wales?
For me, it's digital and data, and the interaction between complex systems, which are more and more digitally driven and digitally represented, and the human in it. So that the human still stays in the center in control. Naturally, there will be fully automated systems as well. So it's at the moment we are looking at a project which takes mass manufacture to the next level, with mass customization of mass manufactured product, where individualized projects are completely digitally captured and taken through the manufacturing place back to the customer on a very compressed time frame. And this is only possible to do it digitally. So it's got elements of supply chain, elements of data capture, elements of metrology verification, and feedbacks at various points from the customer back in manufacturing design. So it's about data and the digital world.
Thanks, Hans. I'm going to just mention a couple of other things. Massive market disruption. You know, we won't know the ownership of personal mobility, public transport, and the models of that will change significantly in the future. I would put that one into it. The realization of our communities that we are completely fragile as regards our basic needs means that there's a demand that we now make things that we were not thinking to make in the past, because they were considered as low cost type activities, and it all fell over. So the customer perception, the people in the street, their perception will change how these things occur. We've got major restructuring in finance and funding activities. Andrew Hopkins' comment about UK government extending funding into industrial challenge funds. Andrew, you know, we'll have to answer that more properly. But we've got a perfect storm really appearing in that time as we move from EU funding back to sort of UK funding. How does that work out of London, out of Wales? The framework changes that Wales are putting forward on these things. And in all this, these seem like the perfect storm, but I also take it as the perfect opportunity to do something that is simpler, better, and more coherent. As we talk about innovation funding, sometimes for those who are not in the funding streams, it's the most complex thing we've ever heard in our life. So simplification, I hope, in the engagement process will be fantastic on that. I'm going to move to the next one. I guess we could continue much longer on that. It's question 3. What support is available to ensuring supply chain sustainability? I think we'll start with Mo.
Yeah, thanks, James. Yeah, so we're doing quite a variety of different activities, both within Astute and wider as well. with regards to this topic. Obviously, there's lots of work being done on closed-loop supply chains, reverse logistics, looking at the whole issue of recycling and remanufacturing, which includes things like inventory control, and also looking at the governance of the supply chain as well. What happens when you move from a linear supply chain to a closed-loop supply chain? Issues to do with regards to remaker spaces as well. There's opportunities there, looking at the remaker spaces and opportunities afforded by 3D printing in that regard. And then the whole issue about green sustainable procurement, looking at the whole issue of local versus global sourcing. We've done some work recently with an organization looking at their procurement decision making, which is predominantly based on cost and price. And we started adding other criteria like environmental issues, looking at suppliers' ability with regards to satisfying environmental requirements, whether or not they had environmental management systems in place, but also looking at the social aspects as well. For example, looking at whether or not suppliers had equality, diversity, and inclusivity policies. And then bringing all that together, multiple criteria, and then making decisions. And this is part of the automation that we will answer about later, is making a decision with regards to who you're going to procure components from. That's very much linked in with resilience as well. But one of the criteria then is what happens when there's a disturbance. How do you cope with disturbances? So you can start adding more and more criteria into that. And I think the key thing, I think Hans mentioned, is that this is very much co-created projects between academia and industry. We take some theoretical models and then apply them in a real practical situation. So going from fundamental research to applied research. And so we actually applied those concepts with a particular company. But I think one of the key issues as well, I think going back to the previous question, is what should be local and what should be global. I don't think we can just say, well, we're just going to be, let's do everything ourselves. I don't think that's viable, at least at the very least from a political perspective as well. Internationalization, globalization is still going to be there. I don't think we can just ignore it.
Thanks, Mo. I'm going to continue to move forward. We have only 7 minutes left, and we don't want to delay you this morning. Question 4, is there any prospect of a UK or Welsh government formulating a industrial or manufacturing strategy? I'll start with Hans, and then I want to jump back on this one, as you imagine, Hans.
Okay, I was about to bounce the ball back straight to you. The Welsh government is working on a manufacturing manifesto, and I believe Phil is in the audience, so he might be able to talk more about it. And it's out for consultation, will be launched soon or has been launched. So for consultation, so there's an opportunity to feedback, and naturally the UK government is working on this as well. Yeah.
So in context within the UK industrial strategies that we've already had, Made Smarter included, the launch is for formal consultation is on Monday. If you've not had the link, I'll ask Astute 2020 to put the link in. You're welcome to attend that on Monday. It's a session led by the Minister of Economy and Transport. And we will launch what is being called the Manufacturing Future Framework for Action. Dismiss the word manifesto and dismiss the word strategy. We need to do a framework for action. 10 themes are being launched on Monday, and we have about 6 to 8 weeks as an industry really to put that together. Fortunately, we spent 5 months between December and April working on that to launch it in April. We had to delay it till now, but no more delay on that. And your input is valued on that, because that will be, if you like, the structure, the framework on what we will do between academia, government, industry, and also employees, representatives as well in that cooperative way. Quite a key session on Monday. First time in my life that I've sort of seen this level of interest to do that. What's right for manufacturing in that. And we ask you to very much attend on Monday, but also to get involved in the consultation in the following 2 months. If we can extend the link on that, Rian, later, that would be great. That I hope may answer the question that we have in the live questions, which is how do you define advanced manufacturing? I'm not going to answer that now. We do answer it on Monday. Do come along. But I will say this: we've run into problems with the word advanced manufacturing over many, many years. People think it's something that is just got semiconductors in it or electronics in it or something very complicated, or what you produce rather than how you produce it or why you produce it. The most significant thing people are looking for is something that is carbon-free, that protects them, that they can eat, that they can live in, that they can enjoy, that they can work with, and anything that contributes towards that advances us as a society. And so you'll probably find the definition is very different on Monday to what you might expect. And hopefully it'll be much more inclusive than it has been previously. We'll move on to question. I'm going to skip my questions because I feel I've talked enough on this. Into question 9, Mo, if we may. There's an opportunity in manufacturing. Is there an opportunity in manufacturing for intelligent automation for business process? I think actually we've answered that, and we had a live question on that one. So forgive me, I'm going to stop again on that particular question. I'm going to go to Gavin. How can we help green the manufacturing industry? Question number 5, Gavin.
Okay, so we've covered some of this already with Mo talking about the green supply chain. I mentioned the circular economy earlier. One of the things, circular economy is not just about thinking about, say, recycled materials and how you can make products more durable. One of the areas is with the circular economy is consumers leasing the products from companies instead of buying those products, which means the company retains ownership of the product. So it's using things such as our digital skills. So using things such as digital twins, tracking of products, once they're out with the consumer, to make sure that they are that they're in good use and that they are responding to the consumer's needs, and being able to get them back at the end of life so that they can be repaired. So think about the kind of digital side of things as well. And also when we're thinking about things such as renewable energy, helping companies make sure that their renewable energy technologies are working appropriately and as efficient as possible, so they're producing as much energy as they can within their product.
Thanks, Gavin. Okay, we are now in our last 30 seconds. I see some significant questions we're not going to get to. We have committed to answer all these questions in written form as well. There are 2 questions in the live questions on ownership of IP. On this, I'm going to hand to Hans first, perhaps, on that issue. It'd have to be a brief answer, Hans, but I'm sure it's something that we can discuss further with the written answers later.
Yeah, I just typed a quick question answer there, but basically the bottom line is each project is collaborative, and it's underpinned by a collaboration agreement where we agree distribution, share, and exploitation of the outcomes of it. Naturally, we need to be state aid compliant, but so far we've always found a satisfactory solution which allows the company to fully exploit the outcomes of this. So please talk to us and we can take you through it. Patents, it's actually quite good if the companies applied for the patents because they've got the capacity to maintain them and exploit them. So again, it's part of the collaboration agreement.
Thank you. I could comment further on that. I mean, never ever let that concern hesitate or stop you from discussing and collaborating. I would say that. Yeah. Because you never find the solution until you can't use the solution until you've found the solution on it. Okay, we've got perhaps question 13. What support exists to encourage manufacturers in Wales to invest in better capital equipment to improve productivity and competitiveness, I guess that is. I'll take that very briefly. Talk to us. Talk to Welsh Government, your regional team in Welsh Government, talk to your local authorities economically, talk to Astute, because signposting to these areas, talk to SMART. They will help you significantly find the windows and the doors by which you can do that. But obviously automating before understanding process or mapping process is not something that we recommend, because it may well be that you can take that process away altogether. So it's to get that the right way around. We're bang on 9:30, and I'm fully aware that people are starting to have to drop off because of the next level of phone conference or meeting that they've committed to. So I'm just going to say first, thank you ever so much to Rian, who in the background has run the session for us today. On behalf of Astute, thank you ever so much, Rian, for making it easy for us. My 3 panelists, thank you again for all that you've put in here. The commitment to all of you online is that every question that we've not answered fully will be written and sent to you as a full answer. So please, including the ones that you put on live this morning. My thanks for your time. All the very best for the day and the near future. We know how difficult it is right now. And even the time you've given up to this point to listen says that you've got your head above the water and you're looking around to find the partners for solution. And I'd thoroughly recommend today that you talk further with the Astute team. The links to the Astute team are in there. The case studies that we've discussed, we're going to put the link to that also into the feedback session. It may drop into the Q&A in the next minute or two. But otherwise, thank you ever so much. If you want further information, email, and the email is info@astutewelsh.com, and you'll find the door to all the parties that we've been discussing with this morning. Thank you ever so much again. Take care.
Thank you.